How does the atomic structure of each element influence its inner electronic binding energy, making it identifiable and specific? What is the significance of the binding energy in terms of material characterization and identification? How does Einstein's law of the photoelectric effect relate to the calculation of electronic binding energy, EB, in an atom? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What role does the photoelectric effect play in understanding the interaction between light and matter, and how does this contribute to the measurement of binding energies? How can the B of an element be calculated using Einstein's law, and what equation or principles are involved in this calculation? What implications does the binding energy have for the analysis of materials using XPS, particularly in identifying elements and their chemical states? How does the concept of binding energy contribute to the broader understanding of XPS as a tool for material analysis? How do variations in binding energy reflect changes in chemical environments or oxidation states of elements in a material, and why is this important in material characterization? What are the potential applications of XPS measurements of binding energy in industries like electronics, chemistry, and surface science, and how can this information be used to optimize material properties? How can binding energy analysis through XPS provide insights into material composition, structure, and even reaction mechanisms at the atomic level? What is Planck's constant, H? And why is it important in the context of calculating binding energy, EB, in XPS? How is the energy of the incident photon, H upsilon, related to the calculation of binding energy, and what role does it play in the photoelectric effect? What is the significance of the kinetic energy, EK, of the electron when it first escapes from the surface in determining the binding energy of an atom? How can the value of binding energy, EB, be calculated by knowing the kinetic energy, EK, of the emitted electron and the energy of the incident photon? Why is EK essential in the process of calculating binding energy, and how is it measured in XPS experiments? How does the relationship between H upsilon, and EK help to provide a precise calculation of the binding energy of an electron in a material? Why is the ability to calculate binding energy crucial for understanding the electronic structure of materials in surface science? How does the knowledge of incident photon energy, H upsilon, help determine the binding energy of electrons and contribute to material characterization? How does XPS leverage the known value of H upsilon and the measured EK to derive valuable information about the chemical environment of the material being studied? What practical applications depend on accurately determining EB through the relationship between photon energy and electron kinetic energy?